The stars have always whispered stories to us. Long before telescopes, before satellites, before rockets ever left Earth, people stood under the night sky and asked the same question: what's out there? The answer, as it turns out, is stranger, grander, and more fascinating than anyone could have imagined. Let's take a journey through space, not by rocket ship, but through imaginations, carried by the facts astronomers and scientists have uncovered. The universe isn't just vast, it's full of surprises. Consider this: the universe is about 13.8 billion years old, and light itself, the fastest thing we know, hasn't even had enough time to cross it all. The farthest galaxies we've detected are so distant that their light began its journey not long after the Big Bang itself. Every time we point a telescope at the deep sky, we are, in fact, looking back in time. Imagine holding a telescope powerful enough to stare across billions of light years. What you would see isn't the universe as it is today, but as it once was, when galaxies were still being born, when stars were larger and more violent, and when the first elements of life were only just beginning to scatter across space. And yet, despite this immensity, the very atoms in your body, carbon, oxygen, iron, were forged in the hearts of dying stars. Every breath you take, every heartbeat, carries with it a history that stretches back to cosmic furnaces older than the Earth itself. Carl Sagan's words ring true. We are made of star stuff. But the universe doesn't only awe us with its age, its sheer scale is almost beyond comprehension. Take our own galaxy, the Milky Way. It's a sprawling collection of over 200 billion stars, stretching about 100,000 light years across. To put that in perspective, if a spaceship could travel at the speed of light, something physics currently forbids, it would still take 100,000 years just to go from one end of our galaxy to the other. And yet, the Milky Way is just one of perhaps 2 trillion galaxies in the observable universe. 2 trillion islands of stars, planets, and mysteries floating in a cosmic ocean. Some of these galaxies collide, dance, and merge in slow-motion ballets that take millions of years. Our Milky Way is already on a collision course with its neighbor, the Andromeda Galaxy. In about 4 billion years, the two will merge into a new giant elliptical galaxy. Stars flung into new orbits, nebulae colliding, and yet, because of the vast distances between stars, very few actual collisions will occur. Space is mostly empty, but don't mistake empty for boring. Even in the void between stars, there are wonders. There are rogue planets wandering the galaxy without a star to call home. There are black holes, collapsed stars so dense that not even light can escape their grip. There are strange signals of radio waves, fast radio bursts that appear for milliseconds and vanish, leaving scientists puzzled. One of the strangest things about space is that time itself behaves differently there. Near a massive object like a black hole, gravity becomes so strong that time slows down relative to the outside universe. If you could sit safely near a black hole's edge, a few minutes for you might mean years passing elsewhere. It's as if the universe has hidden pockets where time refuses to flow the way we expect. And then there's light, the messenger of the cosmos. Light travels fast, but not instantaneously. That means when you look at the sun, you're not seeing it as it is now, but as it was 8 minutes ago. The light of the nearest star, Proxima Centauri, takes over 4 years to reach us. Some of the stars you see in the night sky may already be dead, their light still on its way to Earth like a final message. The story of space is both humbling and exhilarating. It tells us that we are small, but also connected to everything that ever was. And as we travel further in this story, we'll dive into some of the most mind-bending, fascinating details the universe has to offer. From planets made of diamond to stars that could swallow entire solar systems. If you could hop from one star system to another, the surprises would never end. Planets are no longer just dots in our imagination. They're real. Astronomers have confirmed more than 5,000 exoplanets orbiting distant stars, with thousands more waiting to be verified. Each one tells a different story. Some are hot Jupiters, giant gas planets orbiting dangerously close to their suns. Their years last only a few days, and their skies glow with storms of molten metal. Others are frozen worlds, locked far from warmth, with icy surfaces and dark, endless nights. And then there are the rocky planets, some eerily similar to Earth, others utterly alien. One such world is 55 Conqueror A, a planet about twice the size of Earth, orbiting so close to its star that a year there lasts just 18 hours. Temperatures soar to thousands of degrees. What makes it fascinating is what lies beneath. Astronomers believe much of it could be made of diamond, a planet that literally glitters beneath its crust, proof that the universe is far stranger than fiction. Or take HD 189733b, a gas giant about 64 light years away. If you could stand in its skies, which you couldn't since it's a stormy gas giant, you'd witness a horror show. Winds raging at thousands of kilometers per hour, whipping up rain made of glass. Imagine shards of glass driven sideways at hurricane speeds, slicing through alien clouds. It's beautiful, terrifying, and very real. Not all exoplanets are nightmares. Some lie in what astronomers call the habitable zone, the Goldilocks region around a star where conditions might be just right for liquid water. And where there's water, there could be life. Planets like Kepler 452b and TOI 700d have sparked excitement as possible second Earths. The odds of life existing elsewhere in the universe grow stronger with every discovery. And yet, despite all these discoveries, Earth remains special. For now, it's the only planet we know that hosts life. From the microscopic to the human, life here thrives in every niche, which makes one wonder if life can adapt to Earth's deserts, oceans, and even boiling volcanic vents. Couldn't it adapt to alien worlds too? But space doesn't just give us planets, it gives us stars that defy imagination. Consider neutron stars, the remnants of massive stars that exploded in supernovas. They pack the mass of the sun into a sphere only about 20 kilometers wide. To grasp that density, a teaspoon of neutron star material would weigh billions of tons on Earth. Their magnetic fields are so intense they can strip atoms apart, and some spin hundreds of times per second, beaming radio waves like cosmic lighthouses. We call these pulsars, and their steady ticking has been used by astronomers like a natural cosmic clock. Even stranger are magnetars, a rare type of neutron star with magnetic fields 1 trillion times stronger than Earth's. If you were somehow within 1,000 kilometers of a magnetar, its magnetism could literally tear apart the electrons in your body. Luckily, they're far away. Then there are stars on the opposite end of life, red giants. Our sun, in about 5 billion years, will swell into one. As it expands, it will engulf Mercury and Venus, and possibly Earth. Its outer layers will drift away, leaving behind a glowing core known as a white dwarf. That white dwarf will slowly cool, eventually fading into darkness over trillions of years. Every star, like every life, has an end. But in space, endings are beginnings. The death of one star spreads the elements that seed new stars, new planets, maybe even new life. If we zoom out again past stars and planets, we encounter entire cosmic structures. Galaxies don't float alone. They gather in clusters, bound by dark matter, a mysterious substance we can't see, but whose gravity shapes the universe. Beyond clusters lie superclusters, vast webs of galaxies stretching for hundreds of millions of light years. From far enough away, the universe resembles a cosmic sponge, with filaments of galaxies connected by invisible threads and great empty voids in between. We live inside one of those filaments in a structure called the Laniakea supercluster, a sprawling continent of galaxies in an ocean of dark. It's home to the Milky Way, Andromeda, and countless others. Our address in the cosmos is far grander than just Earth or the solar system. It's part of a cosmic city that may itself be just one of countless others. And yet, with all this grandeur, humans have explored only the tiniest fraction. Our farthest spacecraft, Voyager 1, launched in 1977, has only just stepped outside our solar system into interstellar space. It carries with it the golden record, a time capsule of human sounds and greetings, a message in a bottle drifting into the unknown. In 40,000 years, it may pass near another star. Perhaps no one will ever find it, or perhaps someday someone or something will. Black holes are among the most mysterious characters in the story of the universe. They begin as stars, but not ordinary ones, only the giants. When a star several times more massive than our sun burns through its fuel, its core collapses under its own gravity. The result? A region of space where gravity is so strong that not even light can escape. The surface of a black hole isn't really a surface at all. It's called the event horizon, a boundary. Cross it, and there's no return. To an outside observer, anything falling into a black hole appears to slow down, frozen in time as light struggles to escape. But to the unlucky traveler falling in, time continues normally, right up until the point of no return. What happens inside? That's the great mystery. According to Einstein's equations, matter collapses into a singularity, an infinitely small, infinitely dense point. But quantum mechanics, the physics of the very small, refuses to agree. Somewhere in the clash of these two theories lies the answer to what black holes truly are. They're not just cosmic vacuum cleaners, though. Black holes can power some of the most energetic events in the universe. When matter spirals into them, it heats up and emits radiation so intense that entire galaxies can glow with the energy. These are quasars, beacons so bright they outshine all the stars in their galaxies combined. Some quasars are powered by black holes billions of times the mass of our sun. And then there are the giants at the centers of galaxies, supermassive black holes. Our Milky Way hides one called Sagittarius A star, about 4 million times the mass of the sun. It sits quietly now, but in the past it likely blazed as a quasar. The incredible photograph captured in 2019 by the Event Horizon Telescope, a glowing orange ring surrounding a dark shadow, was humanity's first glimpse of one of these monsters. Black holes also bend time and space in ways that can ripple across the universe. When two collide, they send out ripples known as gravitational waves, tiny distortions in space-time itself. First predicted by Einstein, they were finally detected in 2015 by the LIGO Observatory, caused by two black holes merging over 1 billion light years away. The signal lasted less than a second, but it opened a new era. For the first time, we weren't just seeing the universe, we were hearing it. As mind-bending as black holes are, they're not the only cosmic puzzle. Let's talk about dark matter and dark energy. Astronomers have long noticed that galaxies spin in a way that doesn't make sense. Stars at the edges move faster than they should, as though something unseen is holding them in place. That invisible something is called dark matter. We can't see it, touch it, or detect it directly. It doesn't emit or absorb light, and yet it outweighs ordinary matter by about 5 to 1. Without dark matter, galaxies would fly apart. In a way, it's the cosmic scaffolding that holds the universe together. But if dark matter is puzzling, dark energy is even stranger. In the late 1990s, astronomers discovered that the universe isn't just expanding, it's expanding faster and faster. Some mysterious force is pushing galaxies apart, stretching space itself. This force, called dark energy, makes up nearly 70% of the universe, which means that everything we know, stars, planets, people, accounts for less than 5%. The rest remains hidden. The truth is, most of the universe is made of things we don't understand. The mysteries don't end there. Imagine stars that live only a few million years before exploding in supernovas compared to red dwarfs, tiny faint stars that can live for trillions of years. Or consider the fate of the universe itself. Will it expand forever until galaxies drift so far apart that night skies go dark? Will it eventually reverse, collapsing in a big crunch? Or will it tear itself apart in a big rip, where even atoms can no longer hold together? The answers lie far in the future, but our curiosity pushes us to look now. Every telescope we launch, from Hubble to the James Webb Space Telescope, is another eye on the cosmos, peeling back layers of mystery. Webb in particular has already shown us galaxies so ancient they existed only a few 100 million years after the Big Bang, like fossils in the sky, snapshots of creation itself. And even as we gaze outward, we continue to wonder inward. Are we alone? If life exists elsewhere, is it microbial, hiding in underground oceans on moons like Europa or Enceladus? Or is it intelligent, broadcasting signals across the stars? The famous Drake equation tries to estimate how many civilizations might exist in the galaxy. The result? Depending on the numbers you plug in, the answer ranges from "we're utterly alone" to "the galaxy should be teeming with life." If the latter is true, why don't we see evidence of them? This is the Fermi paradox, the apparent contradiction between the high probability of alien civilizations and the lack of any sign. Perhaps advanced civilizations are rare or short-lived, or perhaps they're out there, but so different we don't recognize them. Maybe the signals are coming, but we don't yet know how to listen. Let's come closer to home, our own solar system. It may seem familiar, but it's every bit as strange as the distant exoplanets and black holes we've already explored. Each world circling our sun is a chapter in a story billions of years long. Take Jupiter, the giant of the family. It's so massive that it could swallow more than 1,300 Earths inside it. Its gravity dominates the solar system, tugging at comets, deflecting asteroids, and shaping orbits. Without Jupiter, Earth might have suffered far more catastrophic impacts. In a way, it acts as both guardian and bully. And then there's the Great Red Spot, a storm on Jupiter that's been raging for at least 350 years, maybe longer. It's twice as wide as Earth, with winds swirling at hundreds of kilometers per hour. Imagine a hurricane so large it could cover continents and last longer than entire human civilizations. That's Jupiter's atmosphere. Endless storms, banded clouds, and colors shaped by chemistry we're only beginning to understand. Saturn, though less massive, captures our imagination with its breathtaking rings. From afar, they look solid, like a giant vinyl record circling the planet. In reality, they're made of countless icy particles, from tiny grains to chunks the size of mountains, all orbiting in a delicate balance. The rings are surprisingly young, perhaps only a few 100 million years old. Some scientists believe they might vanish within another 100 million, pulled back into Saturn or scattered into space. We happen to live at just the right time to see them. Beyond Saturn lies Uranus, the oddball. It rolls around the sun on its side, tilted more than 90 degrees. Its poles point where most planets' equators are, probably the result of a massive collision long ago. This tilt gives Uranus bizarre seasons. One hemisphere can spend decades in sunlight, while the other endures decades of darkness. It's also a pale blue world, its color coming from methane in its atmosphere. And then there's Neptune, deep blue and stormy. Though it's farther from the sun, its winds are the fastest in the solar system, reaching up to 2,100 kilometers per hour, strong enough to shred clouds into spirals. Neptune's largest moon, Triton, orbits backward compared to the planet's spin, hinting it was captured from elsewhere. Triton is geologically active, with icy geysers erupting nitrogen gas into space. But perhaps the most intriguing worlds aren't planets at all. They're moons. Take Europa, one of Jupiter's moons. Its surface is a cracked shell of ice, but beneath lies a vast ocean, kept liquid by tidal heating from Jupiter's gravity. That ocean may hold more water than all the Earth's oceans combined. Could something live there, in darkness, under kilometers of ice, warmed by hydrothermal vents as on Earth's ocean floor? Or consider Enceladus, a small icy moon of Saturn. It too hides an ocean beneath its crust. Geysers erupt from its south pole, spraying water vapor and ice grains into space. When the Cassini spacecraft flew through these plumes, it detected organic molecules, building blocks of life. Enceladus has joined Europa as one of the most promising places to search for extraterrestrial life in our own solar system. Then there's Titan, Saturn's largest moon. It's bigger than Mercury and has a thick, hazy atmosphere rich in nitrogen. Its surface features rivers, lakes, and seas, not of water, but of liquid methane and ethane. Imagine standing on Titan's shore, orange skies above, a methane sea lapping at your feet, and frigid air cold enough to freeze you solid. Yet, in this alien chemistry, scientists wonder, could life emerge in a form completely unlike anything we know? Even closer, our neighbor Mars continues to tease us. Dry and dusty now, it shows evidence of ancient rivers and lakes. Rovers have found rocks that could only have formed in the presence of water. Seasonal streaks on its slopes may be caused by salty water trickling down today. If Mars once had oceans and a thicker atmosphere, could it have supported life billions of years ago? If so, might traces still remain beneath its surface, waiting for us to discover? And let's not forget Venus, once thought of as Earth's twin. Similar in size and composition, but with an atmosphere that turned hellish. Thick clouds trap heat in a runaway greenhouse effect, pushing surface temperatures above 460 degrees Celsius, hot enough to melt lead. Its air is suffocating carbon dioxide laced with sulfuric acid. And yet, some scientists have suggested that high in its atmosphere, where conditions are milder, microbial life could conceivably exist drifting in the clouds. Each world of the solar system carries secrets. Mercury, scorched by the sun yet hiding ice in shadowed craters. Asteroids that may be remnants of the early solar system, time capsules from its formation. Comets, icy wanderers that may have delivered water and perhaps even the ingredients of life to Earth long ago. It's humbling to think we've only just begun to explore. Our spacecraft have dipped toes into this ocean of worlds, but much remains untouched. Future missions aim to dive into Europa's seas, to skim Titan's lakes, to dig into Mars's soil. The solar system may hold answers to some of our oldest questions. Are we alone? How did life begin? Could it begin again, elsewhere? If the solar system is a cosmic neighborhood, the next great question is, will we ever move in beyond Earth? Humanity has always been restless, always searching for new horizons. The stars have tempted us for millennia, but only recently have we had the tools to dream realistically of going there. The moon was our first step. In 1969, when Neil Armstrong set foot on its dusty surface, he called it a giant leap for mankind, and it was. But it was also just the beginning. The moon is only 3 days away by rocket. It's a nearby outpost, a proving ground. Scientists hope that in the coming decades we'll build permanent bases there, mining water ice from shadowed craters, using it for drinking water, oxygen, and even rocket fuel. A lunar settlement could become a launch pad to the rest of the solar system. Mars is the next great frontier. Its red deserts, thin atmosphere, and bitter cold make it harsh, but not impossible. Unlike the gas giants or icy moons, Mars has gravity, seasons, and a day only slightly longer than Earth's. It has frozen water at its poles and buried underground. NASA, SpaceX, and other organizations dream of sending humans there within the next 2 decades. Some imagine entire colonies, where domes shield settlers from radiation, greenhouses grow food, and children are born under alien skies. But even Mars is just one world. Beyond lie challenges that stretch imagination. The gas giants are too hostile for colonization, but their moons, Europa, Titan, Enceladus, offer possibilities for robotic exploration, perhaps even human bases in the distant future. Asteroids, too, may be valuable. They're rich in metals and minerals, potential treasure troves floating between planets. Mining them could supply resources for a growing spacefaring civilization, reducing the need to haul everything up from Earth's gravity well. Still, space is not forgiving. Radiation, microgravity, isolation, and sheer distance are enormous obstacles. Our technology is young, but consider this. Just over a century ago, humans had never flown an airplane. Now, we've landed rovers on Mars and probes on comets. Progress, though slow, is relentless. And what lies beyond Mars? The stars themselves. Proxima Centauri, our closest stellar neighbor, is 4.24 light-years away. At today's speeds, a probe would take tens of thousands of years to get there. Yet ideas for faster travel abound. Nuclear propulsion, solar sails pushed by powerful lasers, even speculative concepts like warp drives. Each has challenges that seem insurmountable, until, perhaps, they're not. The Breakthrough Starshot project, for example, proposes tiny gram-sized spacecraft attached to reflective sails. Hit by Earth-based lasers, they could accelerate to a significant fraction of the speed of light. In theory, such probes might reach Proxima Centauri in a few decades, within a human lifetime. Imagine getting postcards from another star system. And if we ever did become interstellar travelers, we would begin to answer one of humanity's most profound questions. What is our place in the cosmos? Right now, we're a Type 0 civilization on the Kardashev scale, a way of measuring technological advancement. A Type 1 civilization harnesses all the energy of its planet. A Type 2 harnesses the power of its star. And a Type 3 harnesses the energy of its entire galaxy. We are far from even Type 1. But if humanity survives long enough, the scale of our reach could grow unimaginably. Picture a Dyson sphere, a megastructure built around a star to capture its energy. To us, it sounds like science fiction, but it's a serious concept in astrophysics. Astronomers even search for distant stars whose light dims in strange ways, hoping to catch a glimpse of such colossal engineering by other civilizations. If such futures await us, they may change not just where we live, but who we are. A species that spreads beyond Earth, that lives under alien suns and sails the dark between stars, will carry new myths, new identities. Yet, wherever we go, we'll carry the same curiosity that first lifted our eyes to the sky. The story of humanity in space is only in its opening pages, and the rest of the universe, endless, vast, and full of mysteries, waits to be written. If space exploration is about humanity's future, then the farthest horizons are about the universe's fate itself. Stars, galaxies, and even time have lifespans. The cosmos is not static. It evolves, and eventually, it will end. But how? Let's start with stars. We've already seen how they live and die. But what about the most massive ones? These giants burn through fuel quickly, living only a few million years before detonating in spectacular supernovas. These explosions can outshine entire galaxies for weeks, scattering heavy elements into space. Gold, uranium, even the calcium in your bones were forged this way. Without supernovas, life as we know it would never exist. Some massive stars don't just explode, they collapse into black holes. Others create neutron stars. In both cases, the end is violent. Yet stars smaller than our sun have a quieter fate. Red dwarfs, by far the most common type of star, burn their fuel so slowly that they can shine for trillions of years. Since the universe itself is only 13.8 billion years old, no red dwarf has ever died. Someday, though, they will cool into dark, invisible remnants. Zooming out, galaxies have lifespans too. Our Milky Way and Andromeda, as mentioned earlier, are on a collision course. Over billions of years, galaxies merge, grow larger, and evolve. Eventually, many will form giant ellipticals, huge, smooth galaxies filled with aging stars. In the far future, night skies may look emptier as galaxies move away from each other faster and faster. This expansion is driven by dark energy, the mysterious force we touched on earlier. Right now, it's pushing the universe apart. But how it behaves in the distant future will decide the universe's destiny. Scientists imagine several scenarios. One possibility is the Big Freeze. In this version, the universe keeps expanding forever. Stars burn out one by one. New stars form more rarely as gas clouds are used up. Eventually, galaxies grow dark. Black holes dominate, slowly evaporating over unimaginable timescales through Hawking radiation. In the end, the universe is cold, empty, and silent, a vast sea of darkness where even atoms eventually decay. Another idea is the Big Crunch. If gravity somehow overcomes expansion, the universe could reverse. Galaxies would draw together, stars and planets crushed until everything collapses into a single point. Some theories suggest that after a crunch, there could be another Big Bang, a cycle of creation and destruction, an eternal heartbeat of the cosmos. And then there's the most dramatic scenario, the Big Rip. If dark energy grows stronger over time, it could eventually tear galaxies apart. Later, it would tear stars, planets, and even atoms themselves into shreds. Space-time itself would rip. It sounds like science fiction, but the equations suggest it could be possible. These fates are distant, trillions upon trillions of years ahead, yet asking about them matters, because it ties back to a question humans have always asked: where is this all going? Even in the nearer future, strange things await. White dwarfs will cool into black dwarfs. Neutron stars and black holes will remain as cosmic fossils. Over quadrillions of years, chance encounters could fling stars out of galaxies. Eventually, even black holes might evaporate, releasing their energy in faint whispers of radiation. The universe may end in silence, or it may collapse or tear apart, or something none of us can imagine yet. Our current theories are like lanterns in a vast cavern. They illuminate a little, but the deeper shadows remain. Still, there is wonder in this. To even contemplate the end of everything is an achievement of human thought. A species on a small planet circling an ordinary star has dared to ask what happens not just to itself, but to the cosmos entire. And perhaps in contemplating the end, we appreciate the present more. Right now, stars still shine, galaxies still glow, life blooms, at least here on Earth. The universe is alive with light and possibility. By now, we've seen the grand arcs of the universe, the birth of stars, the fate of galaxies, even the possible end of everything. But scattered through space are oddities so strange they sound like riddles or science fiction. Let's wander through some of them, like travelers collecting curiosities from a cosmic bazaar. Start with rogue planets. Most planets orbit stars tethered by gravity, but some are cast adrift, flung away during violent encounters or failed solar systems. These wanderers drift through the galaxy alone, with no sun to warm them. Astronomers estimate there could be more rogue planets than stars. Imagine standing on one. Eternal night above, no sunrise, only faint starlight and perhaps the dim glow of internal heat. Some theories suggest that with thick atmospheres or underground oceans, even these lonely worlds might harbor life. Then there's diamond rain. On planets like Neptune and Uranus, extreme pressure can break apart methane molecules, rearranging carbon atoms into crystalline forms. In other words, diamonds. Scientists believe it may literally rain diamonds in their atmospheres, gemstones tumbling through layers of gas until they melt in deeper interiors. A planet where jewels fall from the sky, something no myth ever imagined, but nature quietly does. Even stars come in strange varieties. Some, called hypervelocity stars, are ejected from galaxies at speeds of millions of kilometers per hour. They're flung out when massive black holes slingshot them away, sending them sailing into intergalactic space, alone but burning. Another oddity, quark stars. These are hypothetical objects denser than neutron stars, where matter collapses into its smallest components, quarks. If they exist, they would be tiny, incredibly heavy, and utterly alien. A spoonful would weigh more than Mount Everest. No one has confirmed one yet, but astronomers are watching for signals. And what about the coldest known place in the universe? Surprisingly, It's not a faraway galaxy or deep space void. It's a laboratory on Earth. Physicists have cooled atoms to fractions of a degree above absolute zero, colder than anything naturally found in space. But in the cosmos, the coldest natural spot we've found is the Boomerang Nebula, a dying stars cloud 5,000 light-years away. There, temperatures drop to just 1 degree above absolute zero, colder than the background of the universe itself. Speaking of extremes, the hottest known exoplanet is KELT 9b, a gas giant so close to its star that its daytime temperature reaches nearly 4,300 degrees Celsius, hotter than some stars. Its atmosphere is literally being stripped away by stellar radiation. The universe also plays tricks with time and distance. Take light echoes. When a star explodes in a supernova, light travels outward, bouncing off clouds of dust. Centuries later, that light can reach Earth again, long after the star itself has vanished. It's like hearing an echo of a cosmic event across the vast hall of space. Or consider the odd behavior of pulsars. These spinning neutron stars emit beams of radiation like cosmic lighthouses. Some pulse so steadily that they rival atomic clocks in accuracy. Scientists have proposed using them as a galactic GPS system. If humanity ever travels between the stars, pulsars could guide our way. And then there's the mysterious wow signal. In 1977, a radio telescope picked up a powerful burst of radio waves from deep space, lasting 72 seconds. It was so unusual that the astronomer monitoring the data circled it and wrote, "Wow," in the margin. Decades later, no one has ever explained it. Was it natural, a cosmic coincidence, or perhaps a signal from someone or something else? The truth remains hidden, but the story reminds us how vast our ignorance still is. The cosmos is full of riddles. Why do some galaxies form perfect spirals while others look like chaotic smudges? Why do some stars spin so fast they flatten at the poles? Why are there planets bigger than Jupiter, but lighter than cork, puffed up giants that seem impossible? Each discovery leaves us with more questions than answers. That, perhaps, is the greatest fact of all. The universe is not only stranger than we imagine, but stranger than we can imagine. For all its vastness and strangeness, space has always been a mirror for humanity. Every civilization that has looked up at the stars has tried to make sense of them, to find patterns, to tell stories. Our myths, religions, and art are full of constellations, gods, and omens written across the night sky. The ancient Babylonians mapped planets and stars meticulously, creating the first known star catalogs. They predicted eclipses, tracked Venus across the sky, and began the mathematics of astronomy. The Greeks gave names to constellations, connecting them to heroes and monsters. The Polynesians, thousands of miles from any other continent, used the stars to navigate the vast Pacific Ocean, guiding canoes across thousands of kilometers without compasses or maps. Their knowledge was a living library written in the night sky. In more modern times, space became both a laboratory and a playground for human curiosity. Galileo's telescope revealed moons orbiting Jupiter, showing that Earth was not the center of everything. Newton explained why planets move in ellipses. Einstein revealed that gravity bends light, that time itself can stretch and warp. Each discovery challenged the way we see ourselves, revealing that we are part of a vast, dynamic universe. And yet, despite this knowledge, we are still children of wonder. Think of Hubble's deep field, a single patch of sky smaller than the size of a coin held at arm's length. When the Hubble Space Telescope stared at it for hundreds of hours, it revealed thousands of galaxies, many of them young and forming in the early universe. That tiny corner of darkness became a cosmic city, a visual testament to the universe's immensity. Space also teaches us humility. Look at Earth from orbit, a fragile blue marble suspended in blackness. From that vantage, borders disappear, continents shrink, and oceans dominate. Astronauts speak of the overview effect, a cognitive shift that makes them see Earth not as a collection of nations, but as a single, interconnected home. It's a reminder that, for all our conflicts, we share this planet, and it is finite. But space also inspires ambition. The International Space Station, orbiting 400 kilometers above Earth, is a human-made starship in miniature. Scientists from dozens of nations live and work there, studying microgravity, observing the cosmos, and testing technologies for the next steps, the moon bases, Mars habitats, and beyond. It's a symbol that cooperation can achieve what once seemed impossible. The cosmos challenges our imagination. The thought of traveling to other stars, colonizing moons, or even witnessing the death of a distant galaxy pushes us to dream beyond our limitations. Science fiction, once a genre of fantasy, now often predicts reality. Satellites, lunar rovers, and robotic explorers are all reflections of what humans dared to imagine decades earlier. Even our language carries echoes of space. Words like gravity, orbit, cosmos, and galaxy remind us that we live in a universe governed by laws far older and grander than human history. Philosophers and poets alike have turned to the heavens to ask questions about existence, purpose, and destiny. Ultimately, space is more than a place. It's a story we are still writing. From the myths of ancient people to the spacecraft of tomorrow, the universe calls us outward. It teaches us humility, wonder, and courage. It reminds us that our tiny lives are part of something infinite, and that curiosity, our endless curiosity, is the engine that drives us to explore, to learn, and to imagine. And as we look outward, we cannot help but look inward. Space asks who we are, who we might become, and what our place is in the grandest story ever told, the story of the universe itself. Space is not only vast, it is weird, even by the standards of our wildest imagination. Some cosmic phenomena are so extreme they almost defy logic, yet they exist, proving that reality can be stranger than fiction. Start with rogue black holes. While most black holes reside at the centers of galaxies, some are flung out by gravitational interactions or violent mergers. These nomads drift through interstellar space, invisible except for the subtle bending of starlight or the occasional X-ray flare when they encounter gas. A black hole passing near our solar system could, in theory, disrupt planetary orbits. But the odds are vanishingly small. Even so, the idea of a dark, wandering gravitational monster is eerie to contemplate. Then there are magnetaires, extreme neutron stars with magnetic fields so strong they could erase your credit card from a distance of hundreds of kilometers. Their magnetic intensity is trillions of times stronger than Earth's, and occasional flares release as much energy as the sun emits in 100,000 years, all in a fraction of a second. If one happened near us, it would be catastrophic, stripping away Earth's atmosphere and irradiating the surface. Luckily, the closest known magnetar is safely thousands of light years away. Cosmic strings are another puzzle. These hypothetical, one-dimensional defects in space-time might have formed in the early universe. If they exist, they are incredibly thin, yet incredibly dense, like infinitely long cracks in reality. Their gravity could bend light and warp space around them, and passing near one could have unimaginable effects. They remain theoretical, but their existence would reveal a universe even stranger than we know. Space also surprises us with phenomena that seem to break the rules of time and light. Consider gravitational lensing. Massive objects like galaxies or black holes bend light from objects behind them. This can create multiple images of the same distant galaxy or stretch a single star into arcs across the sky. Observers on Earth might see stars that no one else can see, or even glimpse ghost galaxies warped by invisible matter. Gravitational lensing is both a tool for astronomers and a reminder that space and time are malleable, not absolute. Then there are the fast radio bursts, FRBS. These mysterious signals last only milliseconds, but emit more energy than the sun does in a month. Some repeat at irregular intervals, while others appear only once. Their origins are unknown. Neutron stars, magnetars, or something entirely unexpected. The more we listen, the more we realize the universe is alive with ephemeral, fleeting signals that defy explanation. At the quantum scale, space is equally strange. Vacuum fluctuations mean that even empty space is not empty. Particles spontaneously appear and vanish, flickering into existence for split seconds. This bizarre activity gives rise to phenomena like Hawking radiation, through which black holes can slowly evaporate over eons. A subtle reminder that even the most permanent objects are impermanent when viewed through the lens of quantum mechanics. Then there's dark matter and dark energy, which dominate the universe yet remain unseen. We infer them only through their effects. Galaxies spinning too fast, cosmic expansion accelerating. Ordinary matter, the stuff we see, touch, and breathe, is just the tip of the cosmic iceberg. The vast majority of the universe is a mystery, a shadow world shaping a reality from behind the curtain. Finally, consider cosmic microwave background radiation. This is the faint afterglow of the Big Bang, a relic from the universe's infancy. Everywhere we look, it permeates space, a 2.7 degree Kelvin whisper of the birth of everything. Embedded in this faint glow are subtle variations, seeds of galaxies, clues to the universe's structure, hints of the grand architecture of everything that exists. The universe is a gallery of extremes. Gravity so strong it freezes time. Matter so dense it defies intuition. Radiation so intense it could erase life instantly. It stretches imagination, bending the rules we take for granted. And yet, amid all this strangeness, humanity continues to watch, measure, and wonder. Space is not only a frontier, it is a mirror, reflecting our curiosity, our courage, and our unending desire to understand the impossible. If the universe is a gallery of extremes, then humanity stands at the threshold, ready to step into the vastness. The future of space exploration promises challenges, dangers, and wonders that our ancestors could only dream of. The first step beyond Earth is establishing permanent settlements in the solar system. The Moon, for example, is no longer just a cratered rock in the sky. Future lunar bases may serve as laboratories, mining stations, and launch pads. Water ice in permanently shadowed craters could supply drinking water and hydrogen fuel. Imagine astronauts harvesting lunar resources, building habitats beneath the surface to shield themselves from radiation and meteorites, creating a small outpost in a world without air. Mars looms as the next frontier. Its red deserts are harsh, with dust storms, frigid nights, and thin air. But it has promise. Frozen water, day lengths similar to Earth's, and gravity that is enough to keep humans relatively healthy. Future explorers may live in domed habitats, growing food under artificial light and recycling every drop of water. Terraforming, gradually warming and thickening the atmosphere, remains a distant goal, but even small steps could make Mars a second home. Beyond Mars, moons like Europa and Enceladus offer tantalizing possibilities for life and research. Subsurface oceans could harbor microbial organisms, and robotic probes may eventually drill through ice sheets to explore hidden seas. Titan, with its methane lakes, challenges our imagination, forcing us to consider forms of life unlike anything on Earth. These worlds teach us that habitable doesn't have to mean Earth-like. Life may take many forms, waiting for humans to find it. The farther future might take us beyond the solar system entirely. Projects like Breakthrough Starshot envision tiny laser-propelled spacecraft traveling to Alpha Centauri in decades rather than millennia. Imagine tiny probes racing through interstellar space, sending back images of alien worlds, while generations of humans dream of following in their path. Interstellar travel is difficult, but it inspires innovation. Concepts like fusion propulsion, antimatter engines, or even speculative warp drives stretch the boundaries of physics. Even if we never achieve them, these ideas push our understanding of energy, gravity, and the fabric of spacetime. Humanity may never settle on one star system, but the very pursuit will transform technology, society, and our collective imagination. A long-term future may even include humanity becoming a multi-planetary civilization spreading across the galaxy. This is more than ambition, it could be survival. Earth faces natural risks, asteroid impacts, supervolcanoes, or climate catastrophes. Expanding into space would make our species less vulnerable, creating a safety net for life itself. And beyond survival, space offers transformation. Living in low gravity, under alien suns, or in engineered habitats may reshape humans physically and culturally. New languages, new myths, and new societies could emerge. Children born on Mars might look to the sky and see a faint blue dot, their ancestral home, just as distant and mysterious as the stars to us now. Even in the distant future, humanity may seek the stars themselves, not just as explorers, but as builders. Dyson spheres, massive space habitats, and solar system scale engineering projects may one day harness the energy of stars. Civilizations could become interstellar gardeners, shaping galaxies, preserving life, and participating in the universe's evolution in ways we can barely imagine. The cosmos challenges us with its immensity, its strangeness, and its mysteries. But it also inspires us to rise, to dream, to create. Looking up at the night sky, from Earth or from a habitat on another world, we glimpse the infinite possibilities ahead. The universe is not just a place to observe, it is a place to belong. And the story of humanity among the stars is only beginning. Even after decades of exploration, space continues to astonish us. Consider neutron-star collisions. When two neutron stars spiral together, they release unimaginable energy in a fraction of a second. These cosmic cataclysms create heavy elements like gold and platinum, scattering them across the universe. Every ring you wear, every coin or metal contains material born in violent stellar unions billions of years ago. In a very real sense, the universe's chaos becomes beauty in our hands. Then there are fast radio bursts, enigmatic signals lasting milliseconds, yet brighter than entire galaxies. Some repeat, some vanish forever. We don't know their origin. Alien civilizations? Magneteers? Exotic astrophysical events we've never imagined? Each burst is a whisper from the unknown, a cosmic riddle sent across light years. Black holes continue to stretch our imagination. Supermassive black holes anchor galaxies, yet they are invisible unless feeding. Spaghettification, the stretching of matter into thin strands as it falls into a black hole, is both terrifying and beautiful in theory. In the distant future, even black holes themselves may evaporate through Hawking radiation, leaving nothing but faint echoes in empty space. The universe also challenges our understanding of reality itself. Dark energy drives galaxies apart at accelerating speeds, yet its nature remains unknown. Dark matter outweighs ordinary matter 5 to 1, shaping galaxies while remaining invisible. Most of the cosmos is hidden from our eyes, existing in forms we can only infer mathematically. We are surrounded by mysteries, yet we reach for answers with telescopes, experiments, and sheer curiosity. Space is also full of bizarre orbits and extreme worlds. Tidally locked planets, forever showing one face to their star, have eternal day on one side and endless night on the other. Rogue planets drift through interstellar voids alone. Stars like KIC 8462852, the so-called Tabby's star, dim unpredictably, leaving astronomers puzzled by its unusual light patterns. Each discovery reminds us that the universe has rules, but often rules we cannot fully comprehend. Our own solar system still holds secrets. Oort cloud objects lurk at the edge of gravitational influence. Icy bodies, billions of kilometers away, occasionally flung toward the inner system as long-period comets. Moons like Europa and Enceladus hide oceans beneath kilometers of ice, worlds of liquid water in freezing darkness. Life might be waiting there, invisible to our eyes. Amid all this, space also teaches perspective. Earth, our fragile home, orbits a star in a galaxy among billions. From orbit, continents lose borders, oceans dominate, and human disputes vanish. The cosmos reminds us of both our insignificance and our uniqueness. We are small in scale, yet capable of understanding the vastest scales imaginable. Philosophers and scientists alike marvel at this duality. Life exists on a pale blue dot, yet we reach for stars, measure radiation from galaxies billions of light years away, and calculate the formation of the first atoms. We are tiny, yet curious, fragile, yet ambitious. Perhaps our destiny is to explore, to learn, and to preserve knowledge across the cosmos. The universe may be indifferent to our existence, yet it inspires us profoundly. Every supernova, black hole, and distant galaxy is a story waiting to be understood. Every photon reaching our telescopes is a message from the past, carrying secrets older than civilization itself. The cosmos challenges us, frightens us, and fills us with wonder. But most importantly, it reminds us why we continue to look up. And as we continue that journey through the solar system, through distant stars, through the infinite tapestry of space, we carry with us the most human of qualities, curiosity. The story of space is also the story of us. Time, space, and reality are not as fixed as they seem. One of the most mind-bending revelations of modern physics is that time is relative. Einstein's theory of relativity tells us that time flows differently depending on speed and gravity. The faster you move, or the closer you are to a massive object, the slower time passes for you compared to someone farther away. Imagine an astronaut orbiting a black hole. To them, a few hours might pass. To someone watching from Earth, decades could go by. Time itself stretches and bends, tied to the curvature of space. The universe is not a static stage on which events unfold. It is an active participant in the drama. Relativity also reshapes space. Massive objects bend space-time, curving the paths of light. This phenomenon, called gravitational lensing, allows us to see galaxies that would otherwise be hidden behind other galaxies. Light from the past twists and stretches across the cosmos, creating multiple images or arcs. To look at a gravitational lens is to look at reality itself contorted, a cosmic optical illusion revealing the invisible. Then there are wormholes, theoretical passages through space-time. If they exist, a wormhole could link distant regions of the universe instantly, or perhaps even connect different points in time. While we've never observed one, physicists consider them a solution to Einstein's equations. The idea that a shortcut across light years, or even across time, might exist is one of the most exciting and terrifying possibilities in physics. Even the speed of light has consequences. Nothing can travel faster, which means interstellar journeys are limited by vast distances. A voyage to Proxima Centauri would take years at near light speed, and travelers would experience time dilation, a sort of suspended animation relative to Earth. Long-duration spaceflight is therefore not just a technical challenge, but a challenge to human perception of life and time. Quantum mechanics adds another layer of strangeness. At subatomic scales, particles behave probabilistically, existing in multiple states until measured. Light and matter can behave as both waves and particles. Even the vacuum of space is alive with fleeting energy, with virtual particles popping into and out of existence. Space, empty to the eye, is a seething, restless medium where the rules of classical reality fail. And yet, all these bizarre effects, the warping of time, the bending of light, the jittering of quantum fields, combine to form the universe we inhabit. Stars shine, planets orbit, life emerges. The laws of physics are both strange and beautiful, providing a framework that allows order to emerge from chaos. The implications are staggering. In the far future, advanced civilizations could exploit relativity to travel farther than we currently imagine, using time dilation to jump decades in their lifetimes while centuries pass elsewhere. We might harness quantum phenomena for computation, communication, or propulsion in ways we cannot yet conceive. Through it all, the universe challenges our intuition. What seems impossible in daily life, stretching time, bending light, particles existing in two places at once, is perfectly natural at cosmic and quantum scales. Our senses evolved on a small planet in a quiet corner of the Milky Way. They are inadequate to grasp the full scope of reality. Curiosity and mathematics are our tools for bridging that gap. In contemplating relativity and quantum mechanics, we see that the universe is not only vast and mysterious, but profoundly alien. Yet it is within this alien cosmos that we exist, observe, and imagine. Time, space, and matter may bend in ways we cannot fully picture, but they also allow the very possibility of life, thought, and wonder. Beyond galaxies and clusters lies a universe of emptiness, and it is emptiness on a scale almost impossible to imagine. Cosmic voids are vast regions of space where few, if any, galaxies exist. Some stretch hundreds of millions of light years across, like enormous deserts in the cosmic landscape. To look at a void is to confront true emptiness, where gravity barely holds sway and the night sky is dark, even in theory. Surrounding these voids are superclusters, massive collections of galaxies linked by invisible filaments of dark matter. The Milky Way belongs to the Laniakea supercluster, a colossal structure spanning over 500 million light years. Within these filaments, galaxies move like bees along cosmic highways, drawn together by gravity, dancing in a slow, eternal choreography. The universe has architecture on scales we cannot easily comprehend, vast beyond all intuition. Some cosmologists speculate even further. The multiverse hypothesis suggests that our universe may be just one of countless others. Each could have different physical laws, dimensions, or constants. Some might be sterile and empty. Others could teem with exotic forms of matter, energy, or life. If true, it reframes existence. Our cosmos is no longer the only stage for physics, but one of an infinite ensemble of possible realities. Even more mind-bending is the concept of parallel universes arising from quantum mechanics. In the many worlds interpretation, every quantum choice creates a branching universe. Somewhere, another version of you may exist, making a different decision at every moment. The implications stretch beyond science into philosophy. What does it mean to be unique if every choice is realized elsewhere? Closer to home, the universe itself is still expanding. Hubble's law shows that galaxies recede from us in every direction, a result of the initial Big Bang. Distant galaxies move faster the farther away they are, eventually crossing a horizon where light can no longer reach us. This cosmic event horizon means that parts of the universe are permanently beyond our view, hidden forever. The observable universe is finite, but what lies beyond may be infinite. Gravity, dark matter, and dark energy sculpt these colossal structures, yet their full nature remains mysterious. Dark energy drives expansion, shaping the ultimate fate of the cosmos. Dark matter forms invisible scaffolding, guiding galaxies into clusters and filaments. Ordinary matter, the stars, planets, and living beings we know, represents only a tiny fraction of everything. Most of reality is hidden, yet it governs the visible. Then there are the extreme phenomena at the largest scale. Galaxy collisions, like the impending merger of the Milky Way and Andromeda, remind us that even massive systems are in flux. Supermassive black holes anchor these galaxies, yet they can fling stars outward or even collide with other black holes during mergers. Energy on unimaginable scales courses through the universe, creating quasars, gamma-ray bursts, and jets that stretch light years. Space is both awe-inspiring and humbling. From the tiniest quantum fluctuation to superclusters spanning hundreds of millions of light years, the cosmos operates on scales and with laws that stretch human imagination. Each discovery, from the smallest particle to the largest void, reveals both knowledge and mystery, inviting curiosity, exploration, and wonder. And yet, amid all this, humanity looks upward with hope, not despair. The universe is infinite in scale, complex beyond comprehension, and filled with extremes. Yet we are here, able to perceive it, measure it, and dream of it. The journey of understanding has only just begun, and every answer we uncover seems to create 10 more questions, ensuring that the adventure will never truly end. At the edges of what we understand, the universe becomes almost unrecognizable. Space is not just a void, it's a dynamic, curving fabric, stretching, folding, and perhaps connecting distant points in ways that defy everyday intuition. Wormholes, for instance, are theoretical tunnels through space-time. If they exist, they could link two far-apart points instantly, or even connect different times. The idea challenges everything we think about travel, distance, and causality. While no stable wormhole has been observed, equations in general relativity allow for their existence under exotic conditions. Time itself is another frontier. Near massive objects like black holes, time stretches. In theory, a person orbiting a supermassive black hole could experience minutes while centuries pass outside, a phenomenon known as time dilation. Space may bend time as it bends light, and perhaps even allow glimpses of events that have already happened or will happen. Time, it seems, is not universal, not absolute, and not entirely linear. Then there are cosmic horizons. The universe is expanding so quickly that distant galaxies recede faster than light. Their light can never reach us. There are regions of the cosmos forever beyond our observation, unreachable and unknowable. Our observable universe is just a tiny bubble in a vast, possibly infinite expanse. What lies beyond may follow the same laws as ours, or entirely different ones. Quantum fluctuations add yet another layer of strangeness. Even in empty space, energy blinks in and out of existence. Some cosmologists speculate that universes themselves could bud off from these fluctuations, giving rise to an endless multiverse. Each universe could have different laws, constants, and dimensions. Reality might be far more vast and varied than any human mind can grasp. Philosophical implications abound. If time can bend, if universes multiply endlessly, and if space hides most of its content from view, what does it mean to exist here on this tiny planet at this particular moment? Every life, every thought is set against a backdrop of unfathomable scales and mysteries. Yet this perspective can be empowering. We are observers and participants in a universe that is stranger and more magnificent than any story we could invent. Even phenomena like dark energy and dark matter serve as reminders that knowledge is incomplete. We can measure their effects, but their essence eludes us. Most of the universe is invisible, yet it shapes everything we see, everything we are. The cosmos is a puzzle in which the pieces we hold are only a tiny fraction of the whole. Yet despite this, or perhaps because of it, curiosity persists. Humans continue to send probes, build telescopes, and model reality in computers. We study black holes, gamma-ray bursts, cosmic rays, and the faint afterglow of the Big Bang itself. Every observation is a window into the universe's past, present, and perhaps future. In the end, contemplating these extreme phenomena, the bending of space and time, the hidden scaffolding of dark matter, the possibility of infinite universes, reminds us of our dual nature, tiny and fleeting, yet capable of understanding, imagination, and wonder. The universe is vast, strange, and often terrifying, but it is also a mirror, reflecting our curiosity, our courage, and our desire to reach beyond the boundaries of the known. Humanity may never fully grasp the cosmos, but the journey itself is the point. To explore, to wonder, and to imagine. To reach for what seems impossible is to be alive. And in that sense, space is not only a frontier, it is a teacher, a challenge, and a story that will never end. The universe is full of extremes, places and objects that defy ordinary logic and stretch the imagination. Some of these phenomena are so alien they seem like science fiction. yet they exist, waiting for discovery. Take magnetaires, a type of neutron star with the strongest magnetic fields in the universe. Their magnetic intensity can reach 10 to the 15th power Gauss, trillions of times stronger than Earth's field. A magnetar as close as a few thousand kilometers could erase the electronics on Earth and even distort matter itself. Occasionally, they release giant flares, bursts of gamma rays so powerful they could affect life across light years. Then there are rogue planets, wandering through interstellar space with no sun. Some may be roughly the size of Jupiter, others smaller, yet they drift alone in eternal darkness. Some may carry subsurface oceans heated by radioactive decay, meaning life could exist in worlds that never see a star. The cosmos is a far stranger place than just planets orbiting suns. Stars themselves can behave bizarrely. Blue stragglers found in old star clusters appear far younger than their neighbors, defying expectations about stellar aging. Hypervelocity stars are ejected from galaxies at millions of kilometers per hour, careening through space alone, never to return. And some stars, like KIC8 462852 Tabby star, dim unpredictably, leading scientists to speculate wildly about the cause, ranging from clouds of dust to hypothetical alien megastructures. Even ordinary planets can be extreme. HD 189733b, a gas giant, has glass rain whipped by winds over 7,000 kilometers per hour. On WASP 12b, temperatures soar over 2,500 degrees Celsius, and the planet is slowly being shredded by its star's gravity. And some exoplanets orbit so close to their suns that a year lasts only a few hours. At larger scales, galaxies collide in slow-motion chaos. When galaxies merge, stars rarely crash into each other directly, but gravity distorts shapes, flings stars into space, and funnels gas into central black holes, igniting quasars brighter than entire galaxies. Supermassive black holes at these centers may eventually collide, releasing gravitational waves detectable across billions of light years. And then there are the voids, cosmic regions almost completely empty, spanning hundreds of millions of light years. Traveling through one would feel like drifting in a black desert where stars are distant and rare and galaxies are few and far between. The scale of nothingness is almost impossible to imagine, yet it dominates the universe. On the quantum scale, space itself is strange. Virtual particles pop in and out of existence in the vacuum, creating fleeting energy fluctuations. These tiny blips can have cosmic consequences. Hawking radiation allows black holes to slowly evaporate over unimaginable timescales. Even the vacuum is alive with activity. Then there's dark energy, the mysterious force accelerating the universe's expansion. If it continues, it may one day pull galaxies apart faster than gravity can hold them, leading to a big rip, where even atoms are torn asunder. Most of the universe, the scaffolding holding galaxies together, the force shaping cosmic destiny, is invisible and almost entirely unknown. The universe's extremes are both awe-inspiring and humbling. Magnetars, rogue planets, colliding galaxies, and invisible forces remind us that reality is stranger than fiction. And yet, humanity looks up, studies, and marvels. We are small, fleeting observers, peering into a cosmos that is vast, violent, beautiful, and mysterious beyond comprehension. The story of the universe is endless, and so is our fascination.